Okay, so the question that I have here is a gas occupies 250 centimeter cube at 700 millimeters of mercury and 280 Kelvin. If the volume increased to 400 centimeter cube and the pressure decreases to 500 millimeters of mercury, calculate the new temperature. Right, so the first thing I would want to do here is to fish out the parameters. A gas occupies 250 centimeter cube. That tells us about volume, right? So that tells us that the volume of this gas, which is V1, is equal to 250 centimeter cube. A gas occupies 250 centimeter cube at 700 millimeters of mercury. That tells me about pressure. So my P1 is equal to what? 700 millimeters of mercury and 280 Kelvin. That tells me about temperature, right? So my T1 is equal to what? 280 Kelvin. A gas occupies 250 centimeter cube at 700 millimeters of mercury and 280 Kelvin. These are what we got, right? If the volume increased to 400 centimeter cube, so if the volume, that will be our V2, right? If the volume increased to 400 centimeter cube and the pressure decreases to 500 millimeters of mercury, so my pressure P2 is 500 millimeters of mercury. Calculate the new temperature. Calculate the new temperature. So what I'm looking for is the temperature, which is what? T2. That is unknown. So we have volume, we have pressure, and we have temperature. So the equation that connects these three is the general gas equation. And the equation is P1 V1 over T1 is equal to P2 V2 over T2, right? So our P1 is 700 millimeters of mercury. So 700 times our V1 is 250 times 250 over our T1 is 280 Kelvin over 280 Kelvin equal to our P2 is 500 millimeters of mercury. 500 times our V2 is 400 centimeter cube, right? So times 400 over T2, which is what we're looking for, right? The new temperature. So the next thing I would do here is to cross multiply, right? 700 times 250 times T2 would give us 175,000 T2, right? If I bring out my calculator, 700 times 250, 700 times 250 is equal to 175,000, right? Times T2 will give us 175,000 T2 is equal to 500 times 400 times 280, right? So this is what I have here. 500 times 400 times 280, right? That's what we got from the cross multiplication. Then the next thing is to divide both sides of the equation by the coefficient of this T2, which is what? 175,000, so that the T2 can stand alone. So my T2 will be equal to 500 times 400 times 280 divided by 175,000, right? So if I bring out my calculator, if I punch that, 500, which is this 500 times 400 times 280 times 400 times 280 is equal to this figure, right? Divided by 175,000 divided by 175,000, and that will be equal to 320. So this is equal to 320. So therefore, my T2, which is my new temperature, is equal to 320 Kelvin, right? This is my answer to this question. And if I would want to convert it to centigrade, I will minus what? I will minus 273. So this can also be equal to 320 minus 273, and that will be equal to 47 degrees Celsius, right? So this is the answer. This could also be the answer, right? So the main important thing here to note is to be able to fetch out the parameters and then apply the general gas equation, which is P1 V1 over T1 is equal to P2 V2 over T2.